Alright guys, you're going to need your Chapter 3 packet, Section 5, Write and Graph Equations of a Line. Our central question today, how do you write an equation of a line? Well, to answer that question, we actually have 5 different ways to write an equation. We've got the slope-intercept form, the standard form, the point-slope form, and our 2 special cases, equations for vertical lines and horizontal lines. Let's start with the slope-intercept form. Y equals mx plus b. In this equation, the m stands for the slope, and the b value stands for our y-intercept. This is the place where the graph crosses the y-axis. Now, this form is the best form for graphing. So if the problem asks us to graph the equation, or if it gives us the graph and asks us to write the equation, this is the form we want to go to. The next form is standard form. Ax plus by equals c, where a, b, and c are all integers. Now be careful. This b value is not the same as the b value in the slope-intercept form. Slope-intercept form, this b value stands for the y-intercept. But in standard form, this b is just a number. It doesn't relate to the y-intercept. The next form is the point-slope form. Y minus y1 equals m times the quantity x minus x1, where m is once again our slope, and x1, y1 is a coordinate. It is a point on our line. Next we have our 2 special cases, vertical and horizontal lines. These 2 lines get an equation unto themselves that doesn't really fit the form of the other 3. For the vertical line we have x equals a, where a stands for the x-intercept of our line, the place where the line crosses the x-axis. It's also important to note that the slope of our vertical line is undefined, or has no slope. Last but not least, we have the horizontal line, y equals b, where b stands for the y-intercept. So this b is the same as our b in the slope-intercept form. Again, it's important to note that the slope for our horizontal line is 0 slope. Now be careful not to get these mixed up. No slope and 0 slope are 2 different things. No slope means undefined. It goes with the vertical line, where 0 slope goes with the horizontal line. Alright guys, we have all of our terms. Let's take a look at the examples on the next page. Example 1 asks us to write the equation of a line in slope-intercept form. Well, we've just seen that our slope-intercept form is y equals mx plus b. So what we need to do is identify our slope and y-intercept on this line. Recall from the last section that slope is rise over run. So how high is the line going versus how far across is the line going? Well, let's take a look. If we count point to point, we can see that the line is rising 1, 2, 3, 4 places, and it's going across 1 place. So our slope is a 4 over 1, or just 4. The y-intercept is the place where the graph crosses the y-axis. So if we take a look at our graph, it crosses the y-axis at -3. So that will give us our b value. Putting it all together, we'll get y equals 4x minus 3. And there's our equation. Problem 2. Graph 2x minus 3y equals -12. So this problem is basically asking us to do the opposite of what we've just done. In problem 1, we had the graph, we wanted to write the equation. Now we have the equation, we want to write the graph. Well, the first thing I think we should do is change it to this y equals mx plus b form. Recall that this is our graphing form. In this problem, we're given the standard form. So let's start by converting the standard into that slope-intercept form. In order to do this, we need to solve for y, meaning we need to get y by itself. So let's move the 2x to the other side by subtracting it. Next, we can divide by the -3. And be careful to divide on both sides completely. We want to keep our equation balanced, so we need to make sure we divide both the 2x and the 12. Doing so, we'll find on the left-hand side the -3's cancel. On the right-hand side, we've got negatives canceling here, leaving us with 2/3 x. And then the -12 divided by the -3 will get a 4. Now that we have our equation, let's go ahead and graph it. We can start with the y-intercept, a b value of 4. So on the y-axis, let's go up 4 units and place a dot. Next, we can use our slope, the rise over run, to count to the next dot. Our slope is 2/3, so that's up 2 places and over 3. Up 2 places and over 3. From here, all we need to do is connect the dots. And we have our line. Let's try example 3. The graph shows the cost of having cable television installed in your home. Write an equation of the line. Explain the meaning of the slope and the y-intercept of the line. Well, the first part asks us to write the equation. So we want to do the same thing we did in problem 1. Okay. We've got the graph, so we need to identify the slope and the y-intercept. So let's see what we have. Well, our slope, rise over run. At first glance, it looks like our slope is up 1 over 1, but be careful to look at the units. The number of months we do count in increments of 1, but the y values, the cost in dollars, every one of these increments is going up by a value of 40. So on the grid, even though we're going up 1 unit on the grid, we're actually counting up 40 places. So our slope is actually 40 over 1. Our y-intercept, however, doesn't change. Okay. All we have to do is take a look and see where it crosses the y-axis. And here, we've got a value of 80. So our equation for this line is y equals 40x plus 80. Now this problem asks us to go one step farther and actually interpret what the components of this line mean. We want to know, what is the slope actually telling us, and what is the y-intercept actually telling us? Well, recall from last section that our slope is the change in the y values over the change in the x values. If we look at our graph, the y values are labeled as cost. The x values are labeled as months. So our slope in this problem is actually giving us the cost per month. Now our specific cost per month we found to be $40. So our slope for this problem is a cost of $40 per month. Now the y-intercept, that b value of 80, okay, Again, taking a look at our units here, it tells us that that 80 stands for cost in dollars. So our y-intercept tells us that we are starting at a cost of $80. So what this equation is telling us is that in order to get this cable television installed in our home, we've got to start with an initial fee of $80 and then pay an additional $40 per month afterward. Alright guys, a couple more problems. We're almost there. Example 4. Write an equation of a line passing through the point 2, -3 that is parallel to the line with the equation y equals 6x plus 4. Now the key word we need to focus on first in this problem is parallel. We have to remember from our last section what it meant for lines to be parallel. In section 4 we found out that parallel lines have equal slopes. So the line we need to find has to have a slope that is equal to the slope of the given line. Now taking a look at the line that's given in slope-intercept form, y equals mx plus b, we can find that our given slope is 6. Therefore, our parallel slope must also be 6. Now that we've identified the correct slope, we have enough information to find the equation. All we need to do is take the point that we're given and the slope that we found and put it into an equation. Let's start with point-slope form. Our point-slope form is y minus y1 equals m times x minus x1. All we need to do is plug in our coordinates for our point, 2, -3, and our slope of 6. So y minus a -3 plus 3 equals a slope of 6 times x minus an x value of 2. Now this problem doesn't specify which form to put the equation in. So if it doesn't specify, this would be an appropriate answer. However, let's make sure we know how to get to the other forms as well for when the problem does specify a particular form. Let's next look to get the slope-intercept form, y equals mx plus b. In order to do that, we need to solve our equation for y. So let's start by distributing the 6. Next, we can subtract the 3. And there we have our slope-intercept form. Last but not least, we have the standard form, ax plus by equals c. Now to change from the slope-intercept form to our standard form, we need to get x and y on the same side, and the constant term, the value without the x, on the opposite side. So really, we only have one step left to go. Let's subtract the 6x over to get a -6x plus y equals -15. So there we have standard form, slope-intercept form, and point-slope form. Take a minute now and pause the video and try example 5 on your own. Be careful to note that this problem asks us for a perpendicular line. Recall that perpendicular lines have negative reciprocal slopes. Now that you've finished example 5, be sure to check your answer with the key on my website. And then you can answer the essential question: what are the 5 forms of a linear equation? Alright guys, you finished your homework. We'll see you in class tomorrow.